Here we're given the graph of f of x and we're asked to solve a few things. First, on A, we're asked to solve f of 0. This is saying what is the y value, right? What's the value of the function when x is 0? So I go to my graph, I look at when x is equal to 0, and I notice that there is no y value. So right here, I have a hole that's at x equals 0, but there's no point where it's been filled in. So for example, over here, this has a y value because we have a point that's kind of a solid dot. But here we have nothing like that, right? So technically, there is no y value. We would say D and E here, right? F of 0 does not exist. There is no y value at x equals 0. We go again for B, and we're asked what's the y value when x is 2, right? What is f of 2? Well, I go to x is 2. I look at the graph, and at x is 2, I see here, I do have a y value, right? So if we have a just like line segment, that implies that everything on that segment exists there. I have a y value right at that edge. So this would be a height of 0, right? A y value of 0 when x is 2. So therefore, f of 2 is 0. I do the same thing for C, f of 3. We kind of started to talk about this. F of 3 would be at 3, right? So when x is 3, what's the corresponding y value? Well, the only point that has a solid dot on this is right here at y is 3, okay? So we're just pulling the y values so far. Now we get into the limits, right? So we talked about in class, the limit and the y value are not the same, right? The y value is where I'm located. The limit is what y value I'm getting close to. I don't have to actually exist at that point. I just have to be approaching some y value for the limit. So something like D, I'm asked the limit of f of x as x approaches 0 from the left side, right? From negative numbers. So I look at 0, which is obviously my y-axis here. And as I come 0 from the left side, as I go towards 0 from the left, I'm doing this, right? My graph is moving towards x is 0, right? X 0 right here. But I have to follow the graph to get there, right? You can't just like step across things that are not on the function. So I follow down, 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 down. It looks like I'm going way down to really big negative numbers, which we're going to call negative infinity, right? So in this case, f of 0, or sorry, the limit as x goes to 0 from the left side, I would say that this is going to negative infinity, right? What about as I go towards 0? So E asked me the two-sided limit as x goes to 0. Well, this implies both directions, right? So from the left side, I just established that I'm go down to negative infinity. But from the right side of 0, my limit is actually going to push to a height of 2, right? So if I follow along the left side, I go down to negative infinity. If I follow from the right side of my graph, I go towards 2. Those two things are not the same, right? Negative infinity and 2. Therefore, this limit will not exist, right? So this, I would say D and E, because the left side, so we can write this notation if we wanted to exactly prove it, this notation clearly describes this two-sided limit not existing, okay? Left and right side are not equal. Good. Let's do some others. So as I approach 3 from the right side, what happens to my function? So as I approach 3 from positive values from the right side, I go up, 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 and I approach a height of 2. Remember, there is a y value at 3, but your function is not approaching 3, right? My graph is approaching the height of 2. So my answer here would be 2. Now, does the two-sided limit exist as I approach 3? Well, looking at 3, it doesn't appear to be so, right? The left side here approaches a height of 1. The right side here approaches a height of 2. 1 and 2 are not equal. Therefore, this two-sided limit does not exist. You can say the same claim as what we did for E, right? The left and right side are not equal. What about, let's do our last step here. So we'll take a look at the limit as we go towards negative infinity. So what happens to the function as I push towards negative infinity? Well, remember, negative infinity would push us way over here on our graph, right? So as I go further and further to negative x values, I would go over here, 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 here. And it appears that I'm approaching a height of 1 in that case, right? So this would be equal to 1. There we have it.